Hi students, in this video we're going to introduce and understand the idea of conditional probability. So after watching this video you should be able to know and recall that additional form information can actually alter the probability of an event occurring. After watching this video you should also be able to define conditional probability and identify situations that involve conditional probability given how the question or the situation is worded, and also use a Venn diagram or a two-way table to calculate conditional probability. Things you have to recall: obviously your formulas for calculating probability, and also how to use Venn diagrams and two-way tables. Now, consider the event J, which is that I wear my jacket today. Now, it could be any given day, any given weather, any given season, any given time of year. It might be, 20, 30% that I might wear my jacket on any given day. Now, if I know more information, like if it's a particularly cold day, then the probability I wear my jacket will increase. It might be more like 80, 90% if it's a particularly cold day. So having more information changes the probability of whether or not I wear my jacket. Right? If I know it's cold, the probability of wearing my jacket will increase. If the day is actually going to be hot, then the probability I wear my jacket will decrease. Knowing additional information means that the probability that I wear my jacket will alter and will change. And that happens all the time in different areas of our lives when we think about probability. Knowing more information means the probability of an event happening will change. And this is what we call conditional probability. Conditional probability describes the way how one event happening affects the probability of another event happening. Now, how we write that is the probability of A with a vertical line and then B. Now, how we read this and how we understand this is saying we're finding the probability of A, that's the first letter there, the probability of A, given event B happens as well. Or we can say it another way, the probability again of A happening if B happens as well. Now, how this looks in our Venn diagram, if we're finding just the probability of A, we're saying our whole sample space is the whole rectangle, or the whole situation is our sample space. And then we're looking at the probability of A happening within that sample space. The probability of A given B basically says we're only considering the B event as our sample space. So we're just considering that B circle in our sample space. Right? Those are the only outcomes we're interested in. They're the only outcomes that we are going to consider. And then the probability of A happening, well, if we're just looking at that B circle, A only happens here in the intersection. So these are the only two regions we're looking at. Now, the formula that this gives us is the probability of A given B is the probability of our intersection, which is this part here in the middle, out of the probability of B happening. That's our sample space. That's those are the only values we're considering. Alternatively, we can simplify that, where the probability of A given B happening is the number of times we have A and B in our intersection, or the number in here, divided by the number in set B. Again, we're just considering that B event. We're only considering the elements in there and finding out of those B elements how many are actually in A as well. So our intersection divided by our B value. A good way to remember it is treat this vertical line like a fraction line. So our number in B on the bottom, and then considering the number in B, how many of those are A, that should be on top. All right, so considering the following Venn diagram, we want to calculate a few probabilities here. Probability of P happening, well, P in that circle we've got 10, and in the whole thing, in the whole situation here, the number in our sample space is 30. So 10 out of 30, or 1/3. Now let's find the probability of P and H occurring. Well, that's just our intersection, so that's 4 out of 30, or 2 out of 15. Now, the probability of P happening given H happens. So in this situation, we are only going to consider the H circle. Right? So that's our condition. So we're only looking at our H circle. So on the bottom of our fraction, we're going to write the number of elements that are in H. So looking at that, we've got 4 and 11, 15 is in that circle there. Now, looking at P of those elements, how many are in P? So in that H circle, how many are also in our P circle? Well, it's only 4. 4/15. Now, notice in this answer, compared to our first answer, how our solution has changed. So this number here is actually equal to 3/15. So probability of P happening is 3 out of 15, or 1/5. Oh, sorry, that's 5 out of 15. Right? 5 out of 15 chance of P happening. What's the probability of P happening if we know H happens? Well, the probability drops. It's now changed, it's altered to 4/15 if we're only considering this H circle. Right, now let's work it out the other way. What's the probability of H happening given P? So again, we're just going to look at this P circle here. So in that P circle on the bottom, right, we're only considering 10 elements. So it'll be out of 10. And then in that circle, how many are also in H in our red circle? Again, it's only 4. So that's 2/5, or 6/15. Key thing to notice here, students, is that these values, when we switch the letters around for our conditional probabilities, they are not the same. So the probability of P given H is not the same as, it's not equivalent to P, the probability of H given P. Sometimes they might be the same, but they are not necessarily the same value. They are not always going to be equal. In fact, rarely will they be equal. All right, so in this problem now, we've got a large advertising survey, and it was found that 62% of people enjoy watching the TV show The Office. We're also told that 55% of people enjoy drinking Pepsi. Now, the survey also found that 80% of the people who drink Pepsi also enjoy watching The Office. Now, we've got O being a person watches The Office, and P, the person drinks Pepsi or enjoys drinking Pepsi. Now, we have to display this information in a two-way table. Now, this information we've been given, these are all totals. There's no conditions on these first two statements. So 62% of people in the survey enjoy watching The Office. So looking at O, our total percentage of people is 62%. The percentage of people who enjoy drinking Pepsi is 0.55, or 55%. Now, in total, our total must add up to 100%, or 1, right? We can't have more than 100% chance or probability or likelihood of something happening. So our total there is 1. Now, from here, we're also told that 80% of the people who drink Pepsi also watch The Office. So we've got our value here, 55% of people enjoy Pepsi, 80% of those also watch The Office. So to calculate this value here, people who watch The Office and who like Pepsi, we need to find 80% of 55%, which actually equals 0.44. 0.44. Now from here we can just use some subtraction to help finish filling out our two-way table. So 0.44 plus some number gives us 0.55. That number should be 0.11. Now going downwards, 0.44, adding some number to that should give us 0.62. That number should be 0.18. At 0.44 plus 0.18 gives us 0.62. All right, 0.62 plus some number gives us 1. So if 62% of people like The Office, the remaining 38 mustn't. And in the same way, if 55% of people like Pepsi, then 45% do not, altogether adding to 100%. And then in the middle here, we've got 0.11 plus some number gives us 0.38. That should be 0.27. And then looking at crossways, 0.18 plus 0.27 does end up giving us the 0.45. So this is our table and it all works out well. Now, determine the probability that a random person enjoys Pepsi if they watch The Office. So here we're looking for the probability that a person enjoys Pepsi if they watch The Office. So that means in our table we're considering this value here, at the 62. That's our condition. So on the bottom of our fraction, okay, in our formula, it'll be the probability of someone drinking Pepsi and watching The Office over our probability of someone watching The Office. The probability that someone watches The Office is our total there, 0.62. The probability that a person watches The Office and drinks Pepsi, that is our value up here, 0.44. 0.44. Writing that as a fraction, it'll just be 22 out of 31, or approximately 66 or so percent. So what this means then is if you find a person who watches The Office, there's a 22 out of 31, or about 66% chance that they also like Pepsi. Alright, so after watching this video, you should be able to realize that knowing additional information can alter probability. That's the whole idea behind conditional probability. And then you should be able to define conditional probability and identify situations that involve conditional probability by looking for that if and then statements in your question, and then use either a Venn diagram or a two-way table to calculate conditional probability.